Hey there, this is your host Luke Schantz with the next installment in our series on application modernization. So we have discussed security in every episode because it's that important, but this episode is dedicated to security. And we all know that security is something that is part of the daily operations and every phase of a modernization or development process. But it does need to start somewhere, and that somewhere is with the architect, which brings us to our next guest. We are looping back with Mike Spisak, CTO at the IBM Security Garage.
I could go all day on the security topics. I love the security stuff. But if I had to give a message out to architects and engineers around containerized security and where to start and how to start thinking about these things, because we could go all day about static code analysis and how to automate some of that and right down into the container. Before we go there, I would encourage everyone to take a step back and pull left. And what I mean by that is earlier in the process. So if we go all the way back to the beginning when we start to roll up our sleeves and plan for our new app or plan for the modernization of an existing app. And it starts with things at the architect's level, like threat modeling, something as simple as, hey, let's take the box and arrow diagram that now represents this world that we're about to go into and help identify areas of attack, what we call the attack surface or attack vector, right? What are the things we need to protect? Where are the most sensitive and critical parts of our app? You know, one microservice might be more critical than others. Data, right, is sort of the lifeblood of these apps. So start to understand it from a threat modeling and risk analysis perspective at the architect's level. As we move closer to engineering, start building things like a security backlog of features that need to be addressed, or start to inform ourselves and have just good security and privacy by design early. And then as you move further right and you start to build the code and deploy them into Kubernetes and other types of containerized environments, just doing things like, let's make sure the base host is secure, right? A lot of the basic blocking and tackling that, again, never goes away, firewalls and perimeter types of defense and network defense. But then, assuming that host is secure, let's descend into the container and make sure we're not running things as root. Make sure we're, only the right entities have the right access to the right data for the right reason. Right? This concept of zero trust. And then I'll just close by saying, like, on top of all of that, right, just as an aside, but spending a lot of time in the IBM cloud, and there are lots of really cool facilities available to us there that we can take advantage of to do a lot of this. For example, HyperProtect virtual servers, right, which just allows us to deploy in a virtual server environment using this thing called secure service containers, which kind of takes care of a lot of this for us, and then allows us to safely deploy code into these types of environment into the cloud. So something that developers can use to bootstrap, so to speak.
So there's quite a few ways to approach this depending on your team and your security needs, but it's really important that you do approach security early in your process. And as Mike mentioned, you can dial up or down how much of the security is handled through managed services, or if you're like, hey, no, we've got this, you can handle those things yourself. And over the past few years, there's been a lot of excitement around the orchestration platform, Kubernetes. And we've heard a number of our guests in the series mention it. JJ had some insights into the security aspects of Kubernetes and OpenShift that I'd like to share with you now.
When it comes to general security inside of OpenShift and Kubernetes, the beauty of it is, okay, first of all, security problems happen all the time. If your CIO says we never have a security issue, I'm sorry, they're lying to you. It's just that simple, right? The beauty of Kubernetes and containerization using in a security context is that there are a world of tooling that you can take and check your containers for known vulnerabilities. Now, because of the better practices that Kubernetes and OpenShift force you to use, a lot of the external attack vectors, if you will, of security issues are obfuscated away because of how Kubernetes does the work. You only have a handful of ingress vectors. You can't come in from the side door anymore, especially using Kubernetes. Also, with the containers and building your application, if you set up the proper pipeline, the proper ecosystem around it, using the different registries and the different software out there, it can constantly scan your containers looking for known vulnerabilities inside it. So it's not even running. It's like sitting in its like waiting room at the doctor's office, and it gets scanned and says, oh, look, hey, there's a problem, ship that container back to dev. And there's a whole world of best practices around this. You don't have to go whole hog, and everything has a learning curve. But the beauty of it is over time, as your team gets more versed in this ecosystem and how these things work, it becomes natural, because you're all of a sudden you're like, oh, well, I could just like drop this in right here, and now I don't even have to think about this like downstream at all. Like I can spend my cognitive overhead on doing the velocity that is needed for our developers, instead of me doing the cognitive overhead of having my CIO yell at me. Did I answer your question?
Yes, JJ, you totally answered my question. And thank you for being so generous with your time and knowledge. There is a lot to be excited about with what's going on with containerized workloads and orchestration. And I want to cut to part of my conversation with Andrea Crawford, because she brings up some of the similarities and differences of a containerized and heritage workload from a security perspective, and how they can benefit from some of the tools like Kubernetes and OpenShift that have been mentioned. And then she also talks about the fundamentals like defensive coding and how they're still essential. So let's cut to that.
Yeah, so security with microservices is a little bit of a different ballgame when it comes to securing more heritage workloads. I mean, some things are the same, right? You still have to deal with networks and firewalls and ports. And so in some respects, the attack surfaces have some similarities there. But it's interesting because microservices, because of the granular nature of them, you tend to have this ability to mitigate risk on a much more granular level as well. But you also have a proliferation of microservices that could happen. So it's sort of this, give and take thing. Specifically with security, we must not only think about security in terms of the mechanical differences of containers versus not having containers. So yes, we got to do image scanning. Yes, we have to do pen testing. We have to monitor for mutations for CVEs that pop up in runtime containers. Yes, all of those things. But we must also not forget the fundamentals. We must code defensively. There's this whole notion of a rugged manifesto that really gets developers to think about, when they are developing, expect that they will be hacked. Your runtime container scanning becomes important. But we also must not forget about security at the data layer. So securing data in motion and at rest and in use, whether it's in memory or it's in persistent store. We must also consider security at the networking level. And if you were to get focused in on containerized, there's networking with containers that we have to be concerned about too. So what are your policies around that? So are you going to allow namespace to namespace communication? Yes or no? Are there exceptions? Yes or no, right? What conditions are they? Role-based access control or RBAC, compliance policies, clusters managed by Kubernetes. These are all sort of different constructs that have to be considered when you are really attacking your security approach with cloud native and containers. Some of the perennial zero trust, least privilege, all still apply as they do in the heritage world. But some of our clients really need help in translating that to containers, Kubernetes, and cloud native constructs. So that's where it's a little bit unique.
So I think what Andrea said was super useful to the topic of security, but also really highlights what we were starting to talk about in the beginning of this series. Application modernization is actually a really interesting subject. It's not just dealing with that old thing. It's not just the new thing. It's how all of these things fit together. I digress. Let's continue the tack we were on with our conversation with Andrea and parlay it now to a conversation with Brandon that I think continues the thread we were following.
So Kubernetes security is, like I said, driving that Kubernetes policy, using everything we can within Kubernetes or whatever the orchestrator is, maybe OpenShift, to drive security, right? So there's things such as security context constraints where we can ensure a container can't do certain things, which makes sense, right? Because we don't want to give a container just free will to do whatever it wants, right? We want to basically reduce attack surface and to necessary function, right? So it all kind of boils down into like this least privilege principle, right? Where here's the container, here's what it's for. It should only do what it's for, and everyone to have access to it should only have access if they need it, right? And then comes the vulnerability issue, right? So we scan containers in two different ways. First, we scan a container image, right? So the image is like a template for the container. If we pull an image from an open source library or registry, it might have some vulnerabilities already latent in it, right? So that's where the importance of a container scanner would be. This would detect the image vulnerabilities. We'd be able to not patch it, because you don't patch containers, but update the image or pull a different image that's more secure. And that's the first thing we do. And I would consider that to be one of the more important things you're going to do, right? But you definitely don't want to use a vulnerable image from the get-go. The next thing is scanning images in runtime, right? So there's tools that do both of these, but scanning the container in runtime would point out configuration flaws, something that we didn't catch maybe when we were driving policy. For example, look, we have this container, it's running as root. It shouldn't be able to do that, because then we can't control what it's doing. Or it's out of compliance. It's not encrypting its communication. Its Etsy store is not encrypted. Stuff like kind of scanning for configuration drift and vulnerabilities that pop up in the container. So those are the two ways we typically see containers being scanned there. And they're protected at runtime with that scanner. For example, if we turn on enforcement in the scanner, what it'll do is it'll actually feedback information. If it sees some weird behavior, it can actually isolate the container and basically quarantine it, or it can actually fix the container in runtime to prevent the vulnerability from happening. So some cool stuff there.
Thanks for tuning in to the security episode. And please join us for the next edition in this series, when we will focus on one of the most misunderstood and dark arts of application modernization: refactoring.